Alrighty, so hello and welcome. We're here with yet another programming video. So let's see how this goes. I want to finish what we were working on with Java the other day with respect to Hackerrank. There's like 6 more problems. There was like some studying we were doing on like the Java documentation. I wanted to say I actually there is a Python problem I wanted to show really quickly. I recently had a question from a firm that I solved in Python, and I realized, wow, it's been a really long time. It's been a really long time since I really programmed anything in Python, and I was kind of like, oh yeah, Python should be easy, and then I remembered I don't remember the syntax for Python, and I almost got stuck, and I managed to solve it. But I wanted to show you something. So actually later that day, I went over this problem. It says you're given a function f of x equals x squared. You're also given. I'm just gonna throw this in here too because I don't know when or where to talk about it, but also given k lists, the ith list contains n sub I elements. You have to pick one element from each list so that the value from the equation below is maximized. X sub I denotes the element picked from the ith list. Find the maximized value s sub max obtained. Percent denotes the modulo operator. Note that you need to take exactly one element from each list, not necessarily the largest element. You add the squares of the chosen elements, perform the modulo operation. I'll explain what they're asking in a moment. It's a little confusing from what they wrote. I think it's correct what they wrote, but it's hard to understand for whatever reason. I don't really know why. It's just kind of hard to understand. So the maximum value that you can obtain will be the answer to the problem. Right, fair enough. First line, and then they explain the input. So what they're saying is the first line is how many, let's call them lists that you're going to work with. M is the modulo operator that you're going to work with. And each list, there's an initial value in the front that tells you how many elements there are in that list. So in this case, you have 3, 5, 4, 7, 8, 9, and 5, 7, 8, 9, 10. These are the 3 different lists of numbers. And what they're saying is you want to take of those lists of numbers. There are different possible combinations that you can select. You're going to select one from each, and there's different combinations you could pick, different selections you could make. But each selection is only going to have one from each and exactly one from each. And you're going to square that number, right? Square that number, and you're going to add each of those numbers and add all those numbers together, and then take that final sum modulo m. So take it modulo 1,000. So you might do 25, 64, and 64, which is 128 was 153 modulo 1,000. So 153 would be that selection. And they're saying of all the possible selections you can make, and all of those sums modulo 1,000, they want the largest possible number you can get. So I kind of showed the code already. The solution that I went for was you can use a depth first search and basically loop through for each selection in one set. You can then select, then you recurse by selecting that element, updating your total to whatever your total is plus that element, and then recurse on the remaining sets. And you do that for each element you would recurse. And you would say, and the recursion looks something like, you also, by the way, you can immediately convert all of these numbers to their squares modulo m. So you don't necessarily need to, so it's not going to be these numbers, but you can map them all to their squares modulo m, because modular arithmetic is basically like a times b modulo m is equal to a modulo m times b modulo m, and similarly a plus b modulo m is equal to a modulo b, a modulo m plus b modulo m. The modulo m, it's I guess it would be commutative, associative. I don't know what the right words are. The modular arithmetic. So it plays very nicely under addition and multiplication. I forget the technical term for that, the mathematical term for that. But yeah, so you can make that conversion immediately. So that's what we do. We say we have k and m. We use a list comprehension and on the inputs to get K and M. And what I was going to do initially, as I said, was to use a depth first search recursive backtracking. So, just depth first search. So you would select one of these elements, right? Or you'd loop through all these elements, and each time you would recurse on the remaining sets, and you would just add to the result of that recursion. You would add this element to it, take that sum modulo m, and then compare that to your total. Now, a couple things that there are a few issues there. One, I actually didn't do it that way. I said we're going to maintain a running total in each recursive function call, and then only when we've gone through all of the sets at the end are we going to compare it to like a global variable, and try to take the largest of those values. If I had done it in a way where if you track the values in between, the problem is that because you're using modular arithmetic, you can run into an issue where the largest modular value is actually something that doesn't include the last numbers, for instance. And so once you add the last numbers, you actually loop back, and so the largest value, including it at exactly one of each, you won't get the correct number. So that's actually a mistake that I made, which is interesting, a logical error. But you can avoid that by, instead of using a depth first search, again, the idea is that so what I did was, you have a running total, and you say the base case is once you've sort of finished all of your sets, then you take your total and compare it to the sort of a global, a global variable, like a variable that is you can reach through all of the you can reach through all of the iterations. You can do it that way, and the base case is once you go through all the sets, and the recursive case is you loop over all of the indices in a particular set, and then you update your total based off of the adding this value, the one you're currently looking at. And then after you're done recursing, then you remove that total, and then obviously in the loop you're going to end up, you add the 5, loop through everything, all the possibilities after that, remove the 5, and add 4, loop again, and you kind of just keep repeating. The reason why this works is that you only have, K is 7, so you only have 7 sets, and N is 7. So you only have, looping through everything, you only end up with 800,000, little bit over 800,000 things to work through. So it's actually not bad at all to kind of brute force. It's basically a brute force solution, using a depth first search. So the next thing to consider, though, as I said, is that you're kind of going element by element and then recursing on all the other sets, one element at a time. Yeah, I think you could actually just use you could return the total at the end as well. But you would need some variable that keeps track of like what level you're at. So in other words, if you recurse only 4 sets, you don't want to add those numbers. But if you, or rather, 3 sets here. So only 2 sets. I think before I was talking about it as if there were 5 sets. It's only 3 sets here. So if you only added 2 numbers in your set together, you wouldn't want to take that total. You only want to check against only would want to check against the. You would only want to check your total against the I guess the top level values that you get at the end. Yeah, so I guess you would. Trying to think how could you use return values instead of checking against a sort of a variable that's like a non-local variable. In Python, it would be a non-local variable. I think you would. Just thinking. Yeah. The problem that you run into is that you are taking the maximum. Like you can just at the bottom when you return, I mean, you can just take the maximum of all of the values that you've seen so far. But the problem is that if you do that recursively, then when you run the routine on each of these subroutines, like the subsets, then you end up returning only the maximum of those and applying each value to that maximum, which is not correct. You actually want to apply each maximum to every one of these possibilities. So I think you end up in kind of an unusual situation where I think it's okay, actually. I'm trying to think how to do this properly. Is it okay? Yeah, I think it still works, actually. I don't think you necessarily need to do what I was just saying about having like a non-local variable you can compare to and save the largest. The reason is, excuse me. The reason is that what you return, so once you get off the edge, you can return as 0. Well, you can have your running total. I mean, that's fine. You can still have your running total. I guess. Yeah, you can do it this way, where you have your running total, and at the very top level, you're going to compare that running total at the first function call. You're going to take that running total and return a value, and that'll be the maximum of all the totals that are possible. I think you basically would just ignore the return value for all the other function calls. That's kind of really, I think, what ultimately will happen. And then it's just the first function call is really the only one that matters. I think you could just do it that way. I think that's the simplest way to do it. Yeah, it's fine. That works too. Yep. No problem there. It's kind of hacked a little bit, but instead of using a non-local, but you can kind of always use a non-local. I think in every language you have the ability to do that. In Python, Java, C++, anywhere where you can write inline functions, you can just include a non-local variable that's in scope and in the closure, and that's fine. So you really don't. You kind of always have the ability to do that. So I wouldn't worry about that too much. But for languages where you don't know how to do that, yeah. So, but now what's interesting about this question, why I want to talk about it, is that you might notice I didn't use a depth first search for this. There's only a few lines of code, and this is considered a hard on LeetCode, on Hackerrank. So pretty interesting. You'd solve a LeetCode hard in 4 lines. That's why I want to highlight it. But yeah, so you have what you end up doing is you have the inputs. Each input line is just input. You split, right? So after you get these first 2 values, each line you split and you slice. So I'll explain what this does in a second. But you split and slice the result to remove the first element, because that's what they're saying. Each of these tells you how many elements there are. It's not actually part of the set. So split, use the list comprehension, slice. The list comprehension, the only reason why I'm using that is to we're going to take each of these will be strings, and we're going to convert them to integers. And then we also want to perform this operation that we were describing before. We square it and take it that modulo m. So we just take that string, convert it both twice to an integer. This is kind of inefficient, but it's a lot more concise to do it this way, or in my opinion, it's like a little bit, yeah, it's more concise. Take that modulo m, so convert all those values. So now we have, then we remove the first value using a list comprehension, or using a slice, and then we an array slice, and then we list comprehend these sets for each for each value in k, for each index from 0 to k, excluding k. So we do that k times. So for the k different lines, we get each of these values and we apply this operation. So those are all of our sets, right? And then what we do is we say, okay, ultimately what this depth first search, what's going to do is it's going to basically take every combination we can have. It's really the Cartesian product of each of these sets, and every one of those data points, it's going to find the sum modulo m of all those values. So that's exactly what we do. We take the Cartesian product. We use the asterisk operator to unpack the values, so to product. So now basically this is performing Cartesian product with multiple sets as variables, as parameters, as arguments rather, as arguments. So we have and there's only 7, right? At most 7 of these sets. So each set is another argument to the iter_tools product. We're going to create the Cartesian product tuples of all of the elements, right? And this is going to iterate. This 4 is going to iterate all of those over all of those tuples. Each of those tuples, we convert that to a sum. Take that sum modulo m, and then we want the maximum of all of those and print that, and that gives us our solution. So a lot going on there, but avoids writing depth first search code. And it's very concise. It's a Hackerrank hard, so pretty interesting. In theory, you could solve this problem very quickly, even during an interview, probably in a few minutes if you recognize what you're doing. It took me a lot longer than that earlier, though. Obviously, I mean, it took how much time? 17 minutes just to explain all this. so kind of involved, but pretty neat that you can actually solve the LeetCode hards, or the Hackerrank hards rather quickly, rather efficiently. Yeah, pretty neat, pretty nifty. But again, still not going to work for Google, unfortunately. But this would be helpful if I was going to, right? Because if they asked a question like this, I could very quickly pull out a solution using iter_tools and Python's iter_tools. So yeah, I had an interview in Python earlier, and I just kind of want to highlight, like, it's been a while since I've programmed in Python, so it kind of caught me off guard a little bit. But I was able to, I think, meander my way through it. I kind of remembered how to do certain operations that I needed to use. So, all right, so let's get back to Java. Java exception handling, try catch. Let's go for it. Exception handling is the process of responding to the occurrence during computation of exceptions and anomalous or exceptional conditions requiring special processing. Excuse me, often changing the normal flow of program execution. Fair enough. Java has built-in mechanism to handle. Has a built-in mechanism to handle exceptions, or has built-in mechanisms. Has a built-in mechanism. Using the try statement, we can test a block of code for errors. Using the try statement, we can test a block of code for errors. The catch block contains the code that says what to do if exception occurs. This problem will test your knowledge on the try catch block. You will be given 2 integers, x and y as input. You have to compute x divided by y if x and y are not 32-bit signed integers, or if x is 0, exception will occur and you have to report it. Read sample input output to know what to report in case of exceptions. Input mismatch exception. Arithmetic exception by 0, divided by 0. And input mismatch exception. Okay, so they're not integers. So we're going to read strings, I guess, from standard in. So read 2 lines. So we'll just use next. String A equals, we'll use a scanner. Right, I think we talked about you typically want to use a buffered reader rather than a scanner directly on the input. Have to remember that, but I don't do it that way. Tend not to do it that way. sc.next, b equals sc.next. And we're going to say, how do we know if these are integers or not? Is there a way to check is integer? I don't know. I don't know how to do that in Java. Ooh, excuse me. Oh, it's interesting. So you have value of and you have toString in the integer class. Interpreted number format. Must all be decimal digits except that the first character may be an ASCII minus sign. Values returned. So it's got to be. I mean, you really only have a few options. Either have it's not parsable, or it's parsable as a double or a float. If you can parse it as, actually I don't know. You could check to see. You could parse it as an integer and as a float, and see if they're equal. Maybe. I don't know. I actually don't know how to check this part. I mean, I have some ideas, but I guess if you see a dot in there, you just say it's input mismatch. Yeah. If you see anything other than digits, I think so to do it. There's like a way to custom parse. I think we'll do that. This might be easier here. So we'll say we're gonna have an interface, private interface. We're gonna call this custom parse, and it's gonna have parse. We're gonna use a regex to do this, I guess. I suppose. Boolean parse int, and it's going to be, so actually we can use a consumer, I think, from, well, let's go use a custom interface, it's fine. So custom parse will take a string, and this is going to be abstract, right? And so then we can say, you can say S or, yeah, P to, so our regex is going to be S to actually, it's not going to be a Boolean. It's going to be, really should be an integer. So we'll say character array, array equals s dot to character array, and then we're going to say int ret equals 0. We're going to say for character c in array, if c is greater than or equal to 0 and c is less than or equal to, now I don't know if this actually works, 9, then ret plus equals 10 times ret, or equals rather 10 times ret plus c minus 0, and then else, yeah, return ret. So if it's anything other than a digit, right, it means it's not an integer. Also, we need the sign too. Interesting. So, ooh, okay. Well, we can just say and then we have plus plus I, and I is less than array dot length. Yeah, and we could say sign, determine sign, if array of I, array of 0 really, is equal to negation, or array of I is equal to positive value, right? Then we're going to increment I. Actually, we could say first character. Let's do it this way: character, first character, array of I. And there's another issue of an empty string. Base case. So if s dot equals empty string, throw new, actually just return 0, I think. Handle the empty case. Or is this an edge case? Yeah, more like edge case. Okay, so I'm going to call this parse int, which is parse. Edge case, array, character array, ret equals 0, equals 0, determine sign. First character is array of I. If first character equals negative symbol, say Boolean, positive is always going to initially be true. If it's negative, we say positive equals false. Increment I. First character is equal to positive equals, and we just increment I. Yeah, so we'll do it this way. So actually, we're just writing custom parse code then, I guess. Don't really need to do that generally, but I guess in this use case, we're going to do it that way. Yeah, oh yeah, here we have throw, new, exception. Let's see that. I'm not really sure. So this is, couldn't parse it, we'll say, for this exception. Oh, my nose. input mismatch, and the different types of exceptions. Oh man, my body. Empty stack exception, throw some throwable object. Exception, direct known subclass. Wow. Nice. It's a lot. Unsupported look and feel. Huh. So we just need a throwable, or just an exception. Exception with a message. Okay. Sure. Alright, that's fine. Java.lang. Guess we'll do that too. Oh man. And we can call this a, so this is our lambda expression that we want to use. And we can just call this custom parse f equals new, or just is equal to this lambda expression. My nose. Oh boy. So if we see anything other than integers, so if we see a dot in there, or we see any other characters, then we know it's input mismatch. And we're going to say integer a, so we're going to try integer a equals f of, we'll do x and y. F of a, y equals f of b, catch, throw, new, exception, input mismatch. We'll figure that one out in a moment. What do they want us to return? Okay. (32-bit signed to integers), or if y is 0, exception will occur and you have to report it. Are we returning anything if it works? I don't really know. If it doesn't fit also. If there's an overflow. Do you always get an overflow if you try to multiply? Overflow, underflow. I think it throws an exception in Java. You get overflows and underflows. So, and then we'll say if y equals 0, throw a new exception, divided by 0. Okay, what does this do? Illegal star expression, private. Okay. S. This doesn't need to be abstract. I think, what is this? You say new? You know what? I think this is only for Java 8 that this works. Oops, whoa. What happened? I don't think you have lambda expressions like that in Java 7. Yeah, that's why. Okay, I was wondering. It's like, because I thought I was using something with lambda expressions before, and I was like kind of wondering. I was like, why is this not working? I think it's only for Java 8. Which one is this? 52. Oh. Oh yeah. Interesting. Interface not allowed here. What do you mean? You can't have an inner interface? Oh, no kidding. Ah, my nose. Oh. Privyat. Cannot find symbol f of a, f of b, f of string. Well, it's right here. Why is this causing such issues? Oh, I guess it's f.parse is what it's supposed to be. I guess that's the issue. That must be it. Unreported exception. Exception must be caught or declared to be thrown. Oh, my nose. Oh. I see. I'm going to say throws exception. It's so itchy. Oh. 41. Oh. Okay. Aha. 3. Okay. Interesting. Excuse me. All right, we got this one. Now we want a runtime error, exception, input mismatch, your output, no response, expected output. So input mismatch, exception. Java lang arithmetic exception, input mismatch. My output was 1. Oh. I thought that my parsing code would give me an exception here. That we'd overflow on our integer class. It's kind of interesting. That's interesting. So integer overflow. Or just Java integer. Yeah, I think the Java documentation is pretty good, actually. Hacker's Delight, huh. My nose is so itchy. The inside of my nose. I don't know what's going on in there, but it's not comfortable. Oh, I feel so good to itch. I feel like I'm picking my nose. Huh. Excuse me. So input mismatch exception. Oh, we don't really have to specify that so much. But we want to say if excuse me. Basically, if our number is larger than int max. Oh, my nose is so itchy. Max value. Also, I forgot the sign. I think it's a slightly larger number. He's a long. There's got to be a better way to do this. It's actually not correct. If positive and is greater than integer max value, throw new exception, number's too large, say input mismatch. Not positive and ret is less than integer dot min value. Do it this way, I think. Yeah, I think that's the right way to do it. Something like this. How about that? Yeah, using a long, we just have a few more bits to work with. And so we can sort of contain. Yeah, we could sort of contain the processing. Okay. So, I mean, okay, I guess. So we're saying throw divide by 0. Are we supposed to have I don't actually know what we're doing here. A little confused. We'll just return our main method. What's this other one? Divide by 0. I don't really know what we're doing here with this. A little bit confusing. Handles the test cases. Is that what we're supposed to do? I don't know. Like I said, I'm a little bit confused. This is probably not the right way to do this, by the way. Kind of just did this in an unusual way, but I think you probably would do this with the integer value of, something like that. The problem with the integer value of, though, is like, if you give it a double, I don't think you get an input mismatch. And then also we're printing messages, but we're not really throwing exceptions. I don't know what they're expecting here exactly. Oh, the sample input output to know to report. Okay. I don't know. What happens if we submit? Okay. Well, I guess that's fine. I don't really know. I don't really know what to make of this exactly. Okay, how are we doing? So, yeah, I don't know. Wrote our own custom parsing code. We can always do that, I guess. But I think you could have also just used the. So I guess that also that's something I remember about the lambda expressions in Java is that they actually have they don't create like functional objects exactly. They create more like objects that have a single function that you can call, which is a little bit different than lambda expressions. Lambda expressions in C++ are like strictly functional, like they're actually just functions. These are more like objects that have a single function that you can call. So what else do we have going on here? I don't know, man. What happens if we do test equals integer value of test and test2? Let's see. Test1 and excuse me, test1 and test2. So that's interesting. It does give you a number format exception. Okay, so maybe I didn't need to write my own code. Yeah, you can just do. You can actually rewrite this pretty much the same thing. Parsing is super interesting. So I have my own. Obviously, I have my own way to parse if I wanted to. Yeah, it would be. It would be a little bit less efficient to do this using a long. I mean, you can do it this way. This is fine. There's nothing really wrong with this, but ideally, you don't want to actually sort of allocate more space than you need. You could even go so far as to use. This is really just to detect the value going over or under the minimum and the maximum. Because it's kind of hard to do that otherwise, right? Like, how do you know that multiplying by 10 and or adding this character amount will put you under or over this max value? I guess you could say something like, you could take a difference, I suppose. And so you could say if you're positive, then multiplying by 10 could put you over, which would mean you would need to have multiplying by 10 could put you over if you have what number can you multiply by 10 and that'll put you over? I guess in order for, so let's do the math quickly here. So you want A less than M, we'll call it M for maximum. You want 10A to be less than this maximum. That implies that A is less than the maximum divided by 10. And also you want 10 times A plus alpha to be less than M. That means that A is less than M minus alpha divided by 10. So you subtract this character from M divided by 10, and A's got to be less than or equal to that. Yeah, I think so. Right, because like if we have a 9 as our next character, we divide by 10. Right. Oh, that's interesting. So yeah, you could do it that way. That's better. So you can do if it's positive and minus, so we'll say, int digit equals c minus 0. Integer max value minus digit divided by 10. And ret has to be less than or equal to that. Alternatively, ret needs to be less than or equal to the same thing on the other side. If it's not positive, it's kind of the same thing, except this is sort of negated, so it's going to be, let's say A is greater than or equal to, beta, let's say, or n, we'll say n greater than or equal to n, and we want 10 times A plus this digit alpha greater than or equal to n. The problem is that A is negative and n is negative, so A is less than 0 and n is less than 0 implies 10 times A is even more less than 0, and alpha is not 0 though, so it's you're actually subtracting. So that's the thing, you're actually subtracting this digit because you're negative, because you're less than 0. I think that's the tricky part. Yeah, because I know alpha is always greater than 0, but A is negative. 10, it doesn't matter, that'll be negative, so it's negative, right? So negative 5 to negative 55, you multiply by 10, gives you negative 50, then subtract 5, puts you at negative 55. So then A is greater than or equal to n plus alpha divided by 10. And again, A is negative greater than or equal to, right? So that's interesting. So greater than or equal to this negative value plus this digit. Yeah. It's kind of a subtle thing too. Okay, does that work? Make my parsing code potentially a little bit more efficient. Wrong answer, expected 3, my output. Oh, okay, interesting. Input mismatch. Wait, what? Oh, I got an input mismatch on 10.0? Really? Oh, that's the thing, but ret's not negative. Oh yeah, you gotta do negative ret. I missed that. I think you just do negative. I think that works. Huh. Oh, so it's if these are not true. So if we want these things to be true, then if they're not true, we have a problem. So if A is greater than this M minus, okay, I see. That's the problem. A is greater than, and ret is less than, and negative ret is less than. Okay, I think that's the issue. There we go. Yeah. So that's kind of neat. Let's try and see if that works in all the cases. Okay, but now what's interesting about this is now we don't need to use a long. By the way, we can go back to using an int. I do believe. Let's go for it. Sweet. There you go. So you don't need to convert to long arithmetic. Yeah, using large arithmetic bounds. It's just easier to think about doing it that way, but not necessary. So yeah, this is parsing code. It's probably very similar to what they actually use to parse, in my opinion. Yeah, okay. So we could use that, or we could save ourselves all that extra effort and just run the built-in parsing code. And that seems to work fine too. And that seems to do the same thing. So that's interesting. So what is interesting to me though is the integer parsing does actually consider the case where you're giving a double or float. So that's very interesting to me. So it knows that you're not parsing integer there. That was kind of what I was, I guess what I was addressing. I was like, well, I think in C++, actually your parse int doesn't necessarily throw if you give it a double. I don't actually know, but or a string that represents a double. I don't actually know, but maybe I'm wrong. Maybe it does do the same thing that Java does. All right, neat. So let's go to the next one. Pretty interesting. Java exception handling. Okay. Required to compute the power of a number by implementing a calculator. Create a class myCalculator, which consists of a single method long power int. This method takes two integers n and p as parameters and finds n raised to the p if either n or p is negative, and the method must throw an exception which says n or p should not be negative. Also, if n and p are 0, then the method must throw an exception which says n and p should not be 0 if they're both 0. -5, -4, n or p should not be negative. Complete the function power in class myCalculator, return the appropriate result after the power operation or an appropriate exception as detailed above. Each line of the input contains two integers, lockstep code. Input sends the value, the method has parameters. Excuse me. Each line of the output contains the result n raised to the p if both n and p are positive. If either n or p is negative, output contains n and p should be non-negative. If both n and p are 0, output contains n and p should not be 0. This is printed by the lockstep code editor. So the thing I'm kind of confused about is why the language. What if one or the other is 0? Then what? First two cases n and p are positives. The power function returned the answer correctly. Both are 0. Last two cases, at least one is negative. Exception. Okay. Interesting. Okay, and the exceptions that are thrown, you print the exception. In dot. It's interesting. There's a space, some white space there. Has next NP. My calculator power. NP exception E. also interesting. He does a similar thing to what I do, where I use snake case, mixing and matching the snake case with camel case. Wouldn't recommend that, by the way. So power. So wait. This is long power indent here. Okay. And we're gonna say this throws an exception. And we're not gonna name the exception. Not gonna give it a proper type. Some kind of runtime exception, I guess. So, or argument range exception, something like that. I don't know. There's lots of different exception types. N and P, we want to think about this here. Want Java math power. Should be a power function somewhere in here. Oh, okay. Exponential. E raise to the power of a double value. Get exponent. Oh, this, by the way, is floating point, related to floating point arithmetic. E raised to the x minus 1. XP, EXP minus 1. M1, EXP M1. Pow, there we go. We want pow. We want pow. And we don't have java.math. Pow. Pow, pow, pow. Pow, pow, pow. Pow, 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 pow. Alright. So if A equals 0 and B equals 0. Now I don't know if it's A equals 0 or B equals 0 they want. I'm not entirely sure. Throw new exception. We have this string here that they want, which is and P should not be 0. Okay. Okay, this is negative. A is less than 0 or B is less than 0. And we say N or P should not be negative. Neither N nor P should be negative. Neither N nor P should not be negative. Double negations. Java.lang.math. I think that's what we're after. Or is it just java.lang? Oh, I see. Ah, I see. Whoa. think Java, you always have java.lang. Wrong answer. Java.lang exception, java.lang exception, happy 0. Wrong answer. Oh, I see. Gotcha. That's interesting. That's interesting. All right. See how we do. Oh, that's all they wanted. Okay. Super simple. Fair enough. Exception handling in Java. Got it. Nice. All right. We're not going to go too far with respect to this. That's okay. We're not going to get crazy. Go to the next thing here. Man, I'm tired. I am sleepy. I am ready for bed. Got 4 left. All right, almost there. Almost there. Getting there. There are loads of different exceptions, I think. Yeah, look at all these different exceptions. Runtime exception, timeout exception. I'm looking for exceptions that will probably use my code. Parse exception. Where's number format exceptions that are around here? A, B, C, D. Oh, here we go. It would be L, M, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Yeah, it would be somewhere around here. Where's the number format exception? I saw that before. Ah, it's a throwable. Okay, there you go. It's a runtime exception and an illegal argument exception. So there's a lot of runtime exceptions. Whoa. And then there are also there's illegal argument exceptions, the runtime exceptions, and then each of those more specificity. So there is quite the hierarchy of exceptions in Java. So I guess you are supposed to use the right exceptions. I wouldn't know these offhand. I mean, there's so many of these. So many of these. Yeah, it's a lot. I would just call it an exception. Null pointer exception. There's so many different runtime exceptions. So there are all these different subclasses, and then each of these subclasses have their own. Oh well, probably not. It might just be the runtime exceptions that have many exceptions. How about SQL exception? Try that. Yeah, there's quite a few of these, and then I don't know, serial exception. Does this have any? No, there's not that many, I guess. Maybe like 100 or something. I don't know. It's not, in my opinion, it's not that important to really have the exact correct exception. As long as you have a message that explains what it is, I think you're fine. I think at that point you're fine. They're somewhat not arbitrary, but they're, I don't know, they're very subjective, I guess, maybe the way to explain it. They're like, they just describe different situations that are unusual, and they are really like, in your code you really would have basically unexpected use cases or something, or just unexpected, unusual workflows is really where the exception would go. That's pretty much what exception handling is. It's just on atypical workflow that's technically possible, but is sort of like, well, it's an exception. It's you run a different code path when you run into those situations. Don't do what you would normally do, because what you would normally do doesn't make any sense. But basically, it's kind of like just having bad inputs or bad format, something like that. Okay. Expectedly unexpected maybe is another way to express it. Cryptographic hash functions are mathematical operations run on digital data by comparing the computed hash, i.e. the output produced by executing a hashing algorithm, to a known and expected hash value. A person can determine the data's integrity, for example, computing the hash of a downloaded file and comparing the result to a previously published hash result can show whether the download has been modified or tampered with. In addition, cryptographic hash functions are extremely collision resistant. In other words, it should be extremely difficult to produce the same hash output from two different input values using a cryptographic hash function. Actually, I don't think that's entirely true. Yeah. And actually, there was a firm that I applied to where they explained that that's actually not true. They're explaining the math, and they were saying that you actually get worse case if you use a cryptographic hash function. You'll actually get a worse case collision rate. Yeah, worse collision rate, and the reason is because the average hash, there's sort of like an average case for the hash, and if you use a cryptographic hash, I forget how he explained it. I didn't understand it, I think, or I don't remember. Either I don't remember it or I didn't understand it. But basically, somehow you get a I'm gonna have to go dig through my emails now to see exactly what how he expressed it. That somehow actually it's worse to use cryptographic hash functions. You actually have more collisions, believe it or not, than using a regular hash function. And it had something to do with I actually don't know. I don't know. I have to look and see what exactly was used. I don't know. I'm confused now. I'm not sure. I don't know. I think the issue is if you use a cryptographic hash function for a hash map, then your collisions are actually higher than if you used a regular hash function for a hash map. And the reason is that you are going to be putting your elements into quote unquote buckets based off of the hash values you get. And on the average case, it would be evenly distributed amongst all buckets. But with a cryptographic hash function where you're trying to make sure that you don't have collisions because you're kind of boxed into buckets, then you can only end up with something worse than that average, because you'll end up putting things in you can only end up with something worse than that. I think that's the case. So you actually don't want to use a cryptographic hash for a hash map, but it's good for just regular old hash keys, just hashes in general. Yeah, okay. Anyway, interesting. I think that's the idea. It's very subtle kind of a thing. In addition, extremely collision resistant, difficult to produce the same hash output from two different input values using a cryptographic hash function. Secure hash algorithm SHA-2 is a set of cryptographic hash functions designed by the National Security Agency, NSA, consists of 6 identical hashing algorithms. SHA-256, SHA-512, SHA-224, and SHA-384. 1, 2, 3, 4, SHA-512 over 224 and SHA-512 over 256. With a variable digest size, SHA-256 is a 256-bit 32-byte hashing algorithm which can calculate a hash code for an input of up to 264 minus 1 bits. It undergoes 64 rounds of hashing and calculates a hash code that is a 64-digit hexadecimal number. Interesting. Given a string S, print its SHA-256 hash value. So single alphanumeric string denoted S. S is between 6 and 20. Inclusive size 6 and 20. Size of S is between 6 and 20 inclusive. String S consists of English alphabetic letters, A to Z lowercase and A to Z uppercase, and or decimal digits, i.e. 0 through 9 only. That's alphanumeric. Okay. Print the SHA-256 encryption value of S on a new line. Hello world. Whoop. Simple input. Java RMI 123. Okay, but I don't know. What the question is, what is the SHA-256 encryption algorithm? 256-bit 32-byte hashing algorithm which can calculate a hash code for an input of up to 264 minus 1 bits. Undergoes 64 rounds of hashing and calculates a hash code that is a 64-digit hexadecimal number. Give a string S, print its SHA-256 hash value. Single alphanumeric string denoting S. So 20 characters. So 8 bits is a byte, is a character, right? So 8 times 20 gives you 160. So actually you can do probably quite a bit more than. I think it's 8. Yeah, I think it's 8 bits gives you a byte, and that gives you. I think each character is a byte. So you could have. You could actually do more than 160. You could do more than 20. You could probably do division, right? 263 divided by 8 gives you 32 characters. But I guess we won't do that. I don't know. I'm gonna go 64 rounds of hashing and calculates a hash code that is a 64-digit hexadecimal number. All right, I guess we're implementing SHA-256. I guess we'll go find out how this is implemented. SHA-1 hex hash. That's interesting. What is that, Bitcoin wiki? Oh, okay. There's a Bitcoin wiki now about. Sure. Okay. Set of cryptographic hash functions designed by the United States National Security Agency, first published in 2001, built using the Merkle Domguard construction from a one-way compression function, itself built using the Davies-Meyer structure from a specialized block cipher, whatever that means. Well, I don't know. SHA-2 includes significant changes to from its predecessor SHA-1. SHA-2 family consists of 6 hash functions with digest hash values that are 22, 224, 256, 384, or 512 bits. Novel 256 and 512 are novel hash functions computed with 8 32-bit and 64-bit words. 2, 3, 4, and then there are these two. I don't know what these are. Computed with 8 32-bit and 64-bit words. Respectively, they use different shift amounts than additive constants, but their structures are otherwise virtually identical, differing only in the number of rounds. SHA-224 and SHA-384 truncated versions of SHA-256 and SHA-512 respectively, computed with different initial values. SHA-512 over 2424 and SHA-512 over 256 are also truncated versions of SHA-512, but the initial values are generated using the method described in Federal Information Processing Standards, FIPS, published 184. SHA-2 was first published by the National Institute of Standards and Technology as a U.S. federal standard. FIPS, the SHA-2 family of algorithms are patented in U.S. patent 6829355. The United States has released the patent under a royalty-free license. Yeah, the government having patents is like kind of an obnoxious thing. As of 2011, the best public attacks break pre-image resistance for 52 out of 64 rounds of SHA-256, or 57 out of 80 rounds of SHA-512, and collision resistance for 46 out of 64 rounds of SHA-256. Don't really know what that means exactly, but that's interesting. All right, so there's some other things involved. Okay, interesting. Okay. The Merkle Domguard construction of Merkle Domguard hash function is a method building collision-resistant cryptographic hash functions from collision-resistant one-way compression functions. This construction was used in the design of many popular hash algorithms such as MD5, SHA-1, and SHA-2. Merkle Domguard construction was described in Ralph Merkle's PhD thesis in 1979. Ralph Merkle and Ivan Domguard independently proved that the structure is sound. That is, if an appropriate padding scheme is used and the compression function is collision resistant, then the hash function will also be collision resistant. Padding scheme is used and the compression function is collision resistant, then the hash function will also be collision resistant. Okay, the Merkle-Domguard hash function first applies an MD compliant padding function to create an input whose size is a multiple of a fixed number. Example given 512 or 1024. This is because compression functions cannot handle inputs of arbitrary size. It's because compression functions cannot handle inputs of arbitrary size. The hash function then breaks the result into blocks of fixed size and processes them one at a time with the compression function, each time combining a block of the input with the output of the previous round. In order to make the construction secure, Merkle and Domguard proposed that messages are padded with a padding that encodes the length of the original message. This is called length padding or Merkle-Domguard strengthening. In the diagram, the one-way compression function is denoted by F and transforms two fixed length inputs to an output of the same size as one of the inputs. The algorithm starts with an initial value, the initialization vector. The IV is a fixed value algorithm or implementation specific. For each message block, the compression or compacting function F takes the result so far, combines it with the message block, and produces an intermediate result. The last block is padded with zeros as needed, and bits representing the length of the entire message are appended. See below for a detailed length padding example. To harden the hash further, the last result is then sometimes fed through a finalization function. The finalization function can have several purposes, such as compressing a bigger internal state, the last result, into a smaller output hash size, or to guarantee a better mixing and avalanche effect on the bits in the hash sum. The finalization function is often built by using the compression function. Note that in some documents a different terminology is used. The act of length padding is called finalization. Okay. What is this gibberish? What are they expecting me to do? I guess we're not going to use this additional step here, because that would make things really challenging, wouldn't they? It's definitely like I actually really don't care that much. I mean, I guess it's good that it exists, but it's just not that interesting to me. You know, it's like, okay, great, things are more secure. Woo, great. Yeah. One-way compression function. It's like it's about as interesting. I don't know. I shouldn't say that, but it's about as interesting to me as it is to remember to lock my door at night. It's not very interesting. You just have to remember to do it. But anyway, I don't know. One-way compression function, right? In cryptography, I mean, it is interesting, but it's just, I don't know. I guess I'm just not that interested at the moment. Cryptography, a one-way compression function is a function that transforms two fixed-length inputs into a fixed-length output. The transformation is quote-unquote one-way, meaning that it is a difficult given a particular output to compute inputs which compress to that output. Excuse me. One-way compression functions are not related to conventional data compression algorithms, which instead can be inverted exactly. Lossless compression or approximately lossy compression to the original data. One-way compression functions are, for instance, used in the Merkle Domguard construction inside cryptographic hash functions. One-way compression functions are often built from block ciphers. Some methods to turn any normal block cipher into a one-way compression function are Davies-Meyer, Matches-Meyer, Osias, and Miyaguchi-Pranil. Single block length compression functions, and MDC2, Meyer-Schilling, MDC4, Hydros, double block length compression functions. These methods are described in detail further down. MDC2 is also the name of a hash function patented by IBM. Okay. Excuse me. Compression function mixes two fixed length inputs and produces a single fixed length output of the same size as one of the inputs. Oh, interesting. This can also be seen as that the compression function transforms one large fixed length input into a shorter fixed length output. For instance, input A might be 128 bits, input B 128 bits, and they are compressed together to a single output of 128 bits. It's equivalent to having a single 256-bit input compressed into a single output of 128 bits. Some compression functions do not compress by half, but instead by some other factor. For example, input A might be 256 bits, and input B 128 bits, which are compressed into a single output of 128 bits. As a total of 384 input bits are compressed together to 228 output bits. The mixing is done in such a way that full avalanche effect is achieved. That is, every output bit depends on every input bit. Oh, okay. Interesting. Okay. A one-way function is a function that is easy to compute but hard to invert. A one-way compression function, also called hash function, should have the following properties. Easy to compute. If you have some inputs, it is easy to calculate the output. Pre-image resistance. If an attacker only knows the output, should be infeasible to calculate an input. In other words, given an output h, it should be infeasible to calculate an input m such that hash of m equals h. Second, pre-image resistance. Given an input m sub I, whose output is h, should be infeasible to find another input m sub 2 that has the same output h, which is, i.e. hash of m1 is not equal to hash of m2. So it's pre-image resistance and the second pre-image resistance. It's kind of the same thing. M1 doesn't necessarily need to be M2, but if it's a function, this actually kind of implies the same thing. Collision resistance. It should be hard to find any two different inputs. Yeah, how is something not a function? Actually, in software, you basically only have access to functions. You don't really have access to relations. I mean, you can define relations using software, but like the way that software operates, it doesn't. Usually, it's not. They're pretty much defined to be functions. You have inputs and outputs that are like clear, but a relation is actually like basically. It's not that two different inputs give you the same output. It's that they're more like data points in a Cartesian plane, if you can imagine that, and that would be sort of your relation. So things are so A could be related to B, and C could be related to D, and what makes it a function is that if A equals B, then f of A equals f of B. But you could be in a situation where A could actually end up being two different values, and B, so even though A and B are equal to each other, in other words, the function doesn't point to a single output for a given input. It actually could be multiple outputs, and that makes things a little bit confusing. Now you can map that to a function by just calling that a set of outputs. But then you have kind of an issue though, because yeah, I mean you can have behavior like that where it's not the same thing though. It's hard to express, hard to explain, but yeah, basically you could have functions that return multiple values, but those multiple values would be like a set of values, and that really wouldn't be multiple values. It really would just be one value. But you could have, if you have relations where basically multiple output points are related to a single point, the issue you run into is you don't necessarily know which points you're looking at from a given input. So like a circle is a good example. If you look at the x coordinates of a circle and you draw a line on an x coordinate straight through a circle, you'll see that it will cut through, typically, unless you're on typically will cut through 2 points, right? If you had you were right in the middle of a circle, I guess, and you drew a line straight down through it, it would be 2 points. So it's considered not a function, because sort of f of x there would actually give you 2 points. Now again, you could actually consider that to be a set of points, but that's sort of how you define a function, is that it's actually not. You're not mapping to a set. You're mapping to a single value, and yeah, I mean, like that's, I guess the thing that's kind of confusing is that you can, as I said, that would be just a relation, not necessarily a function. But like I said, you can actually have it would be not a function if you intended to map, if you relate values from the set of integers to another set of integers. But if you intended to relate a set of integers to, if you related the set of integers to the power set of integers, or to, well, it would be the power set of integers, yeah, because you have some subset of integers. Then actually that could be a function rather than a relation. So the function as a notion is somewhat ambiguous, in the sense that it's not ambiguous, but you can relatively easily just change the domain of what your relation is operating on, and then it can become a function. If you change the domain of your relation to the power set of the original domain, then relations that wouldn't be considered functions can become functions. That's what I'm trying to say, which is like a very simple thing, but that seems to be the truth. So yeah. Anyway, collision resistance. It should be hard to find any two different inputs that compress to the same output, i.e. an attacker should not be able to find a pair of messages m_1 not equal to m_2 such that hash of m1 is equal to hash of m2. Due to the birthday paradox, see also birthday attack. there's a 50% chance a collision can be found in time of about 2 raised to the n over 2, where n is the number of bits in the hash function's output. An attack on the hash function thus should not be able to find a collision with less than about 2 raised to the n over 2 work. Oh, interesting. Huh. Birthday paradox, birthday attack. I don't really understand this part, but I guess what they're suggesting is that more bits is less likely to collide, which means that two messages that are not the same give you the same hash. And yeah, I'm not entirely sure. I guess that's what the birthday attack is, birthday paradox. Just keep guessing different possible messages until you get one that matches. Something like that. That is related to the pre-image resistance, right? And the second pre-image resistance. Yeah. Another image that gives you the same output. Even if the input's not the same, the collision is related to this first pre-image resistance. That I understand. This part I don't really get, but anyway, maybe birthday paradox or birthday attack is just basically trying to guess the pre-image. Ideally, one would like the infeasibility and pre-image resistance and second pre-image resistance to mean a work of about 2 raised to the n, where n is the number of bits in the hash function's output. However, particularly for second pre-image resistance, this is a difficult problem. Interesting. The Merkle Domguard construction. A common use of one-way compression functions is in the Merkle Domguard construction inside cryptographic hash functions. Most of the widely used hash functions, including MD5, SHA-1, which is deprecated in SHA-2, use this construction. A hash function must be able to process an arbitrary length message into a fixed length output. This can be achieved by breaking the input up into a series of equal-sized blocks and operating on them in sequence using a one-way compression function. The compression function can either be specially designed for hashing or be built from a block cipher. The last block processed should also be length padded. This is crucial to the security of this construction. This construction is called the Merkle Domguard construction. Most widely used hash functions, including SHA-1 and MD5, take this form. When length padding, also called MD strengthening, it is applied, attacks cannot find collisions faster than the birthday paradox, 2 raised to the n over 2, and being the block size of it in bits. If the used function is collision resistant, hence the Merkle Domguard hash construction reduces the problem of finding a proper hash function to finding a proper compression function. Second pre-image attack, given a message m sub 1, an attacker finds another message m sub 2 to satisfy hash m sub 1 equals hash of m sub 2 can be done according to Kelsey and Schneier for a 2 raised to the k message block message in time k times 2 raised to the n over 2 plus 1 plus 2 raised to the n minus k plus 1 minus 1 or minus k. Is that plus 1 or minus 1? It's plus 1. Note that the complexity of this attack reaches a minimum of 2 raised to the 3n over 4 plus 2 for long messages when k equals 2 raised to the n over 4 and approaches 2 raised to the n when messages are short. Interesting. Okay, but how do I actually perform this? Construction of block cipher from block ciphers. Davies-Meyer. Oh, dude, this is a lot of reading for one Hackerrank problem, man. This is annoying. Davies-Meyer, Matthias-Meyer, Asias, block ciphers, Mayaguchi-Peniel, high-rows, sponge construction. Sponge construction can be used to build one-way compression functions. So I guess my question is, like, how much of this do we need to compute ourselves? Oh, you know what? I think Java actually has a, oh, I think that's the point. I think the point is that Java has a built-in SHA. I think that's the idea. Security. Yeah, there you go. The message digest class provides applications of the functionality of a message digest algorithm such as SHA-1 or SHA-2, 2256. And here I am about to go write my own hash algorithm. Message digests are secure one-way. The reason they call it MD is not because the message digest, by the way. As far as I know, it's Merkle Domguard, but okay, maybe I'm wrong. I don't know. I don't know why they would call it message digest, but that's interesting. That's funny. Oh, maybe. Probably the people who put this together would know better than I do, right? Presumably. Let me not. I read one Wikipedia article, right? Let me not. Let's not. Message digests are secure one-way hash functions that take arbitrary size data and output a fixed length hash value. Excuse me. A message digest object starts out initialized. The data is processed through it using the update methods. At any point, reset can be called to reset the digest. Once all the data to be updated has been updated, one of the digest methods should be called to complete the hash computation. The digest method can be called once for a given number of updates. After digest has been called, the message digest object is reset to its initialized state. Implementations are free to implement the clonable interface. Client applications can test clonability by attempting cloning and catching the clone not supported exception. MD get instance, MD update to chapter 1, TC1 MD clone, byte, chapter 1 digest, chapter 2, make digest a partial constant. Given implementation is not clonable, it is possible to compute intermediate digests by instantiating several instances. The number of digests is known in advance. I have no idea what they're talking about here. I'm just looking for like a simple, just call the function, get the output, print it, done, get it on our way. This class is abstract and extends from message digest SPI. For historical reasons, application developers should only take notice of the methods defined in this message digest class. All the methods in the superclass are intended for cryptographic service providers who wish to supply their own implementations of message digest algorithms. Every implementation of the Java platform is required to support the following standard message digest algorithms. Okay. These algorithms are described in the message digest section of the Java Cryptography Architecture standard algorithm name documentation. That's a mouthful. Consult the release documentation for your implementation to see if any other algorithms are supported. So we'll figure out how to use that shortly. What does Java stand for? Just realized that Java is probably an acronym. History, okay. James Gosling initiated the project in 1991. Oh, dude, so Java's from the 90s. Wow. From 1991, they created Java. Brother, that is such a long time ago. Oh boy. It's 30 years old, this language. I think I attended university 10 years ago. So I was already 20 years old by the time I went to uni. What's interesting about Java is, wow. Oh, I want to know what what Java stands for. Why'd they call it Java? Java was originally designed for interactive television, but it was too advanced for the digital cable television industry at the time. The language was initially called Oak, after an oak tree that stood outside Gosling's office. Okay, yeah, I was gonna say, like, the names for programming languages and programming technology is like always interesting to me because they're kind of, I don't know, how they're named is kind of unusual. Project went by the name Green and was finally, so Oak, Green, Java, from Java coffee, a type of coffee from Indonesia. Cosling design Java with C, C++ style syntax that system and application programmers would find familiar. Indeed. So it was Java Coffee. Okay. Jerva. And yeah, I had a Chinese roommate who would say it as Jerva. Oh, it's so painful, Jerva. Jerva is so painful. Which I got a kick out of. I appreciated it. I thought it was funny how he would say it. Wasn't funny that he was in pain, because that's what he was referring to. His homework assignments were painful. That's what he was saying. Jerva is so painful. Jerva is so painful. But anyway, all right. Okay. Specified algorithm name protected. So returns a clone. So we want to get instance. And then update, I guess. String algorithm provider. Returns a message digest object in place to specify digest algorithm. And there's a provider and a string. I don't know what these two do. Providers. Provider of this message digest object. I don't know what that is. Set the digest for further use. String representation. Update the digest using the specified byte. Updates the digest just using the specified array of bytes. Update byte buffer. Update the digest using the specified byte buffer. Updates the digest using the specified array of bytes starting at the specified offset. So I don't know what any of this does or means. Clone completes the hash computation by performing final operations such as padding. Performs a final update on the digest using the specified array of bytes that completes the digest computation. Completes the hash computation by performing final operations such as padding. Returns a string that identifies the algorithm independent of implementation details. So I guess we just get an instance and then digest. I don't get it. Update to chapter 1, TC1 is a clone, TC1 digest, chapter 1 digest, update to chapter 2. I don't get it. Alright. Java security tutorial. It's the only way. So here I am thinking this is going to take a few hours to solve the rest of these problems, and nope. Security features. Running programs, developers, admins, runners, policy, controlling applications, API, tools for secure code and file exchanges, signing code and granting it permissions, exchanging files, generating verifying signatures, implementing your, let's try signatures. Digital signature, public and private keys. It's not really what we're looking for. Well, okay, let's see. DSA, it's not really what we're looking for. RSA either. We're looking for SHA, something SHA related. Let's see if we just type in SHA. Oh. I don't know. Oh boy. There's a lot to go over here, huh? Okay, so security providers. The Java security provider class encapsulates the notion of a security provider in the Java platform. It specifies the provider's name and lists the security services it implements. Multiple providers may be configured at the same time and are listed in order of preference. When a security service is requested, the highest priority provider that implements that service is selected. So this is just totally like unfamiliar to me, whatever I'm reading here. Applications rely on the relevant getInstance method to request a security service from an underlying provider. For example, message digest creation represents one type of service available from providers. To request an implementation of a specific message digest algorithm, call the method Java security message digest getInstance. The following statement requests a SHA-256 message digest implementation. Without specifying a provider name. All right, this is kind of what we're trying to do, I think. We want SHA-256 message hash computation, right? We want to do that, so presumably that's what we're doing here. Illustrates how this statement obtains a SHA-256 message digest implementation. The providers are searched in preference order, and the implementation for the first provider supplying that particular algorithm, provider B, is returned. Request without specifying provider framework, message digest. Don't really care what these providers are or what they do. Optionally request an implementation from a specific provider by specifying the name. Following statement requests from a specific one. Provider C. I don't know what this gibberish to me, man. Following figure illustrates how the statement requests message digest implementation from a specific provider. How do I use it though? Implementation from the provider that's returned even though a provider with a higher preference order supplies this implementation. Okay, don't really care about that. Whatever that is, not meaningful to me. C, Java cryptography. Okay. Interesting. Number of built-in default providers that implement a basic set of security services could be used applications. Note that other vendor implementation of the Java platform may include different sets of providers that encapsulate vendor-specific sets of security services. The term built-in default providers refers to the providers available. Implementation. Excuse me. Okay, so I guess what they're saying is that depending on how your Java implementation is put together, you have different options. Actually, I don't really care very much about. Oh, wait, isn't that what we just? What? It's literally just like the next section. Okay, fine, whatever. File locations. Okay, sure. Don't really care about file locations. Cryptography Architecture is a framework for accessing and developing cryptographic functionality for the Java platform. It includes APIs for a large variety of cryptographic services, including the following. Yes, it's kind of funny. It's like I could read about how to use their API to do what I want to do, or I can go learn how to write the algorithm from scratch to do what I want to do. Oh, it's fun. Probably should learn both, realistically. Probably should learn both, but okay. So it includes APIs for a large variety of cryptographic services, including the following: message digest algorithms, digital signature algorithms, symmetric bulk and stream encryption, asymmetric encryption, password-based encryption, password-based encryption, elliptic curve, cryptography, key agreement algorithms, key generators, message authentication codes, MACs, and secure random number generators. So for historical export control reasons, the cryptography APIs are organized into two distinct packages. Excuse me. Java security and Java security packages contains classes that are not subject to export controls like signature and message digest. The Java X crypto package contains classes that are subject to export controls like cipher and key agreement. The cryptographic interfaces are provider-based, allowing for multiple and interoperable cryptography implementations. Some providers may perform cryptographic operations in software, while others may perform the operations on a hardware token, for example, on a smart card device or on a hardware Cryptographic accelerator providers that implement export-controlled services must be digitally signed by a certificate issued by the Oracle JC Certificate Authority. Oh man, none of this do I really care about, or is it particularly relevant to what I'm trying to do? Oh, great. Wonderful. I mean, it's relevant in the sense that I'm grateful that these things are built in, but it's not relevant in the sense that I'm just trying to use it. Just want to use it already. Okay. Excuse me. Lots of yawning. PKI. Okay. Alright, we gotta kind of hurry up here a little bit. This is taking too long. It's funny. I just made a video about kind of related to security, and similarly, just made a video related to security, and also I was watching a lecture on really security. On it was actually a sermon. Excuse me, not a lecture, a sermon on security, and the pastor was explaining that the world is afraid of death, and so safety and security are like top priorities in scripture. In the Christian worldview, safety and security is not a virtue. In fact, safety and security is actually one of the lowest priorities for a Christian. The top priority is that the gospel is heard, and security and safety falls quite far below that that calling. That priority is very low priority compared to the other priorities. Although safety and security is important, but it's not a high priority comparatively for a Christian. Whereas with the world, safety and security is like the highest priority for most of the time, to the point where it's a higher priority than life itself, right? Than being able to live. In many cases, that's actually the reality, the truth, which is very interesting how that could be the case. I guess the simplest way to put it, life is not secure inherently. So trying to make it secure inherently means you actually exclude it, so you don't have life, so you cannot actually live. And that's something that's sort of suffocating. The suffocation of big government is one of those key elements, is that you actually like murder your own population, which is pretty wild, pretty crazy, pretty interesting. But I'm reading through all of this security related technology, and I was thinking, yeah, all this junk just to do what you would normally do, but feel better about it, quote unquote, feel secure about it. Very interesting. I mean, there is such a thing as like being so insecure that you can guarantee that something's going to break. But not everything is like that. And there's this big difference between certainly breaking if you don't secure it. In other words, like not tying something down and just hoping that it happens to stay there where it's supposed to be, when you know it definitely won't. there's a difference between that and securing things in a way where it's not very, you don't even necessarily know how likely it is that someone's even going to be able to, and usually it's someone or something's going to be able to throw things off the right path. Something like that. Anyway, interesting. Not saying that it's not good to have some of the security protocols and things that we do have in the internet. In the internet, I think the internet is a little bit of a different game because you have a lot of people actively trying to break into things. Like I said, I suspect my own browser right now is like compromised. I think I may have a cookie on there that's not supposed to be there, because when I search things, you'll see the text doesn't quite look right. It kind of looks like a little bit unusual, and that makes me think that my browser might be compromised somehow. What you can do though is you can just clear your cookies, which I think is what I'm going to do, and that reset your data in your browser, and I think that'll clear things out. I think I'll be in a better spot if I do that. I don't want to do that yet though. Still kind of not ready yet to do that. I think I'll do that tonight before I go to bed. Okay, so Java SASL API. All right. Well, how do I use as SHA 256? How do I actually do that? XML processing. Oh, that's interesting. Okay. I guess it's the message digest, whatever that is. I don't even know what that is or what to do with that. Maybe you just update the message digest with bytes. Maybe that's what you're supposed to do. I was trying to find some tutorial on message. You know, let's do it that way. Message digest tutorial. That should work. That'll give us what we're looking for, hopefully. Well, these other folks will show you how to do it, but Oracle doesn't have a tutorial on this. No, not really. Excuse me. All right, whatever. Well, all right. I think we're gonna do this. We're gonna use the byte input. We're just gonna use digest to get another byte array. I think that's the way we're gonna do this. So we have Java. It's not util. It's java.security.message digest, or java.security. Now we're going to create a message digest. We can say our string to bytes. I think I made this a lot harder than it needed to be. Something like that. To a byte array rather than a character array. Get bytes. Platform's default character set, using the given character set, using a named character set. I don't really know what that means, but I think we'll just use the default. So just get bytes. So byte array, input bytes equals s dot get bytes. I think that's what we said, right? Bytes, byte, 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 byte. Message digest MD is going to be get instance. This is abstract. I don't really know. Shaw 256 get instance static. md.digest or to update input bytes. Now my question is, do we digest them or do we digest? Yeah, I think that's all you do is just digest it, which is a weird thing, but okay. And then return new string of these bytes. Presumably that'll create a string. Oh. Oh, okay. Convert those bytes to a string. Unreported exception. Okay, I guess. That's fine. Wrong answer. Nice. Okay, well, we did something. Huh. Interesting. Nice. Huh. Oh, constructors are what we're looking for, right? Decoding the specified array of bytes using the flash word forms default character set. Can we use hexadecimal? Character set name. Interesting. Okay. a named mapping between sequences of 16-bit Unicode code units and sequences of bytes. What? This class defines methods for creating decoders and encoders and for retrieving the various names associated with the character set of this class are immutable. This class also defines static methods for testing whether a particular character set is supported, for locating character set instances by name, and for constructing a map that defines every character set for which support is available in the current Java virtual machine. Support for new character sets can be added via the service provider interface defined in the character set provider class. All the methods defined in this class are safe for use by multiple concurrent threads. Character set names. Named by strings composed of the following characters: uppercase letters, lowercase letters, digits, dash. So this is A through Z, hyphen, minus, plus sign. Character set name must begin with either a letter or a digit. Character set registration procedures. Character set. 7-bit ASCII. Interesting. So it's supposed to be hexadecimal, right? First things first. What happens if we do these things? Okay. So what's interesting is get these bytes, get these input bytes, digest them, we get a return, print the length, we get 32 bits, 32 bytes, which is interesting because we're trying to get 64 bytes, 64-digit hexadecimal number. I think that's okay, right? So a hexadecimal number is 2 bytes. Excuse me. A byte is 2 hexadecimal numbers. So this is correct. This actually is 32 characters is 8 bits. A byte actually is 2 hexadecimal numbers. So really we just need to convert this to hexadecimal. Interesting. So we're just going to have a character array of, so we'll have SHA bytes. Ret is going to be new character array of size 64. And we're going to say for each byte B in SHA bytes, oops. We're going to set ret get it this way. Right, so we're going to, for each I, I'm going to say 2 times I, so we have int A is going to be 2 times I, and B equals A plus 1, or 2 times I plus 1. And could use an array list for this too. That might be better than using an array. I kind of like that actually. Yeah, it's easier. That's a little bit more cleaner. Go back to what we had before. That's quite a bit cleaner actually. So we're going to add 2 characters for each per byte. So it's interesting that the character itself though is not going to be described by a one byte. So that's the thing that's kind of peculiar. The characters are actually going to be described by the 4 bits represents. It's not a character, but we're converting it to a character. So that's, I guess that's part of this. It's kind of interesting or strange is that the bytes are fine. You do have the 4 different bits per hexadecimal number. However, we're printing that, and so we've got to actually convert that to the appropriate characters, printing the hexadecimal value. So that's a little weird. So, but I think this is it. This is how you actually perform that math. Is you just get a message digest and then digest the input, and that's it. I think it's that simple. Excuse me. But here, what we're going to do with bytes is take the first 4 integers. Take the first 4 bits, convert that to a hexadecimal value. So we say int x is equal to b, and which would be 1, 2, 3, 4, 1, 2, 3, 4, b. I don't know how exactly to write that as a binary value, something like that. But this number is it's a mask. So it's going to be really 16, I think. What's the first 4 bits? And we can call it a byte mask too. It's not yeah, that's fine. It doesn't really matter. Int mask, int byte, however you want to do it. Maybe it's, yeah, it's fine. So it's not 16, it's 15. Excuse me. It's 15, and then we're going to say mask equals mask. So we're going to bit shift to the right 4, and then y is going to be in mask, and then bit shift to the right 4 times. This is bit shift to the left 4 times, excuse me. So you bit shift that to the right 4 times. And then what you're going to do is convert x and y to hexadecimal. So I don't know if there's like a 2 hex. I could write my own, but I can also, if there's one available already, we should use that. just one hex here. 2 hex string. There we go. Hex integer to hex string of I. There we go. And then now we're going to say, now I want to convert this to a string. Well, that's interesting. Actually, maybe we do want a character array then. Take that back. Character list to a string. Can we do that? Maybe we do want a character array then. String builder, string buffer. Let's try a string builder. Maybe we just take a string builder and append all the characters to it. Maybe that's what we should do. And then we can always create a string out of the string builder. Maybe that's what we want. Something like this. Let's see what happens. Oh, interesting. Oh, so these are strings. Alright, maybe we'll just write our own then. Yeah, that's fine. We'll write our own. So we'll say if x is greater than or equal to 0 and x is less than or equal to 9, then we just add integer x. It's going to write kind of like a lambda function here. but we're not going to do that. We're just going to duplicate the code for now. -0 as a character, or I think it's just X. Yeah, if it's a digit, we can add it directly. Same thing with Y. Well, okay, we'll do else if X is greater than or equal to 10, X is less than or equal to, also these are ints, right? So 0 to 9 plus 0, right? Create a character. And if it's greater than or equal to 10 and less than or equal to 16, then we have A through Z, so we just add A, can subtract 10, X minus 10 plus A, hopefully this works, and do the same thing for Y as well. Again, there's some like kind of significant amount of, I guess, duplicated code here, but let's see if this makes sense. Add int. So X should be, I don't actually know about this. It's one of the problems with duplicated code. All of your changes need to be cascaded each time. Don't really need spaces between our operators. I kind of tend to prefer spaces though, even if I don't always use them. Oh, okay. Oh, almost exactly what we're supposed to do, except apparently these are reversed. Apparently you want to swap these two. Why that would be the case, I don't know. That's super interesting. Whoa, neat, we did it. Had a little bit of custom code in here. We probably didn't need to write, I guess. But why is why is the right side of the byte not the part that goes in first? That's kind of interesting. I don't want to look. I don't want to look. Oh, that makes sense. I get it now. So, because if you're pushing these into an array, if you take the right part first and you push that on first in, right? That goes on the left side, and then the next one goes on the right of that, to the right of that, right? So you'd end up swapping, you'd end up crossing the two. I get it now. I get it. That's a subtle thing. That's very subtle. But that's exactly what would happen. You actually want to do, yeah, you'd want to add these in reverse order. If you're grabbing them right to left, you want to add them left to right to have the correct sequence. Okay, so we don't need to write our own SHA algorithm. You know, fortunately, didn't need to do that. But yeah, the subtle thing here is that we did need to, wanted to convert each of these 4-bit values to a character, which a character is actually a byte, I think. Usually, it's not actually 4 bits. So I had to I went with converting to integers, and then each of those integers can be modified to characters, the hexadecimal version of that integer to a character. So yeah, I mean, this is okay. This is one way of doing it. Hexadecimal. Yeah. If we used a character array directly, we wouldn't need to use a string builder. I mean, this is fine. And it looks like you can actually print the string builder directly. Pretty interesting. Okay, we got there. So yeah, I mean, pretty awkward. How much more time do we have? We're at wow, 2.5 hours, and we're looking at where are we? 3 more challenges left. Oh boy. Okay, I think you know what we're gonna do. We're gonna copy paste this code because I think we're gonna need something like this. I don't know if this is the best way to do this, quite frankly. Probably not. Seems like this might be kind of questionable. We'll copy. We'll just go to the next one. That's fine. We don't really need to clean this up too much. It's okay. It's not really that. My opinion, it's probably fine. You know, there's actually. Let's go to Java. And let's go to. There's another one that's MD5. Yeah, that's what I'm looking for. We're going to use basically the same code for this one as well. I've never seen this before, and I thought about it, and I thought, oh, you know, it's an unusual request. Yeah, it's pretty much the same question. MD5 message digest algorithm 5 is okay. That's what they call it, message digest. Okay, I see that. That's interesting. I'm surprised it's not MD as in what is it, Maya Domler or something like that. It is message digest. Okay, so I was wrong. I was running my mouth before. But one wiki, Merkle Domguard. That's what I was thinking. Yeah, Merkle Domguard. I was thinking MD might stand for Merkle Domguard, but it's a message digest. Okay, so it was Merkle Domguard and message digest. So they were correct. Okay, yeah. I mean, of course, like why would I read one wiki article and I think that's yeah. Forgive me for that. It's arrogant and silly and ridiculous. Widely used cryptographic hash function with a 128-bit hash value. Here are some common uses for MD5. Store a one-way hash of a password. Provide some assurance that a transferred file has arrived intact. MD5 is one in a series of message digest algorithms designed by Professor Ronald Rivest of MIT. 1994. However, the security of MD5 has been severely compromised most infamously by the Flame malware. In 2012, the CMU Software Engineering Institute essentially considers MD5 to be cryptographically broken and unsuitable for further use. That's interesting. Given an alphanumeric string denoting a password, compute and print its MD5 encryption value, alphanumeric string S, alphanumeric MD5 encryption, and on a new line, so you get the hex values. Yeah, so we just change this to MD5, really. I mean, quite literally the same code. Can I find symbol? Is it util? Is it security? What is it? Java security, Oracle. I forgot which package this was in. So I get it now. So I feel like kind of a dummy now after learning how this is supposed to be used. Java security message digest. Just do Java.security. Thinking we can do it, use from there. Oops, didn't mean to do that. All right, let's go for this. Okay. Yeah, I mean that's not a very. That's kind of not that interesting of a question. I mean, it would be interesting to have to develop this message digest. If you were to either have to write your own implementation of the message digest algorithm, that would be pretty interesting. And then also there is, if you had to, even more difficult would be coming up with that on your own. So I've said this many times in the past that like a lot of software development, like the tricky thing about it really is, there are a lot of things that have already been developed that like you wouldn't, like I keep saying this about like if this was an interview question, like this could be an interview question potentially, I mean maybe, but like it could technically be one. You wouldn't be able to solve this problem without knowing ahead of time that you can use Java to do this in this way. Either A, you'd have to come up with the algorithm on your own, which is just impossible in 1 hour, right? Just like literally impossible. And the other option is you would have to figure out how to use Java to do this, which also you probably wouldn't do that in an hour, right? That took a while. Even knowing, you'd have to even know that you could do that in Java. So there's this kind of like, also factory pattern, I think. There's this kind of like, I don't know. You have to study, and basically with software engineering, you must study, and it is from memory. Like that's kind of what I'm trying to say. Is like for the most part, quote unquote, being a software engineer really is a matter of like reading and studying more than it is trying to figure things out on your own. Like that's kind of a farce. People talk about that, like, oh yeah, an interview, like they want to see how you think. It's like that's just not true. That's just not true at all. Like really, who knows? It's kind of arbitrary, like what they're even doing during interviews. They're kind of just a random hodgepodge. The reality is that like you only are going to know enough about something if you learned it. If you read it and learned it. Otherwise, you're looking at like designing your own PhD theses, which is just like, it's kind of arrogant to think that like you can come up with something novel and new or whatever in like an hour during an interview or something like that. Like it's checking how someone's thinking is kind of ridiculous as a notion. It really is just like getting a feel for like how familiar they are with whatever domain they're working in. That's kind of it. It's kind of it. Everything else is like, meaningless. because it, like as I said, it's not you. Like as a developer, the things you're using are not developed by you. You're really just accessing the wealth of knowledge that people have put together over the years, and basically lots and lots of PhD theses. It's kind of what it comes down to. So, yeah, TLDR interviews are a little bit ridiculous for software engineering firms, for software engineers. But anyway, so I don't know. I mean, it's a career path I chose. I'm here now. I don't know. You know, what are you gonna do? It's like can't go back and change what I chose to do in life, but you can definitely point out that like these are the kinds of things I'm talking about when I say like interviews are really, really more than anything else a matter of like knowledge and practice. And not just even practice, but knowledge. It's more about knowledge than anything else. Reading and studying and all of that. So, anyway, moving on. Yeah, this is a really good example. Like if you asked a question like this in an interview, it's relatively easy to do in an interview, but you would be impossible if you didn't have the knowledge to do this. You know that you can just use one of Java's libraries. It's built in already. It's super straightforward. Just one digest routine and then convert that to hex, which is not that hard to do. Even to do that manually, it's not that hard. But there's probably a routine to do this a lot more cleanly too. There's probably a much cleaner way. Anyway, yeah. So that's great. So I got two more things and then we're out of here. So I think I see a message from someone. I don't know if that's spam or what. Let me just see if. Oh. Okay. Yeah. So all right. Let's see. What are we doing here? Given a class solution and its main method in the editor, your task is to create the class add and the required methods so that the code prints the sum of the numbers passed to the function add. Var args simple addition. You're given a class solution and its main method in the editor. Your task is to create the class add and the required methods so that the code prints the sum of the numbers passed to the function add. Your add method in the add class must print the sum as given in the sample output. Given a class solution and its main method in the editor. Your task is to create the class add and the required methods so that the code prints the sum of the numbers passed to the function add. Your add method in the add class must print the sum as given in the sample output. Your task is to create the class add and the required methods so that the code prints the sum of the numbers passed the function add. I think we saw something like this before. Your add method in the add class must print the sum as given in the sample output. You are given a class solution and its main method in the editor. You're given a class solution, its main method in the editor. Sorry, I briefly looked at the text and now my mind is like a different universe. Oh man, dude, life's hard. I didn't read it, but I just noticed who it was from, and then it looked like one of those things that might require some attention. So I'm just now my mind is like, what could it possibly be? What could it be? Excuse me. You are given a class solution and its main method in the editor. Your task is to create the class add. You're given a class solution and its main method in the editor. Okay, that's typical. Task is to create the class add and the required methods so that the code prints the sum of the numbers past the function add. So you have add and you have methods so that the code prints the sum of the numbers past the function add. Okay. Your add method in the add class must print the sum as given in the sample output. So we did some var args before, so I think this shouldn't be too difficult. 6 lines of input, each containing integer. There will be only 4 lines of output. Each line contains the sum of the integers passed the parameters to the add in the main method. Oh yeah, we had a thing here where they didn't, what do you call that? The in. Yeah, they didn't use system.in. They just used in, and they said it was intended that way. So you could figure out how to use static import All right, so add, and then we had, so it's variadic is what we're looking for. Excuse me, and I think we just want to print these, right? Each call is going to print it. Sample output. Yeah, so I think each call is going to print it. Let's see. 1 plus 2 plus 3 plus 4 plus 5. Sample input. 1, 2, 3, 4, 5, 6. Okay, so we have an add operator here, and yeah, void add. And we want an integer array, so we just int ... and we're going to call vals or params, something like that. And we're actually going to, so we can say we want a string, so we're going to use a string builder again. String builder, SB, it's a new string builder. And we're going to say for each parameter, except for the first one, so for int I equals 0, I is less than params.length. This is just really just an array. And if I is not equal to, if I is not equal to 0, so it's greater than 0, we're going to sb.append, we're going to add a plus sign before we add the integer, call it character. Really, it's a character. Params of I is an integer, and we add to that 0, and we create a character. I think this works. Convert the character to an integer to a character, and then add 0 to it. Or is it the other way around? I think it's the other way around. I'm not sure exactly how this works. We could try this way. I think before I had to enclose these in parentheses. Yes, we add C, and then at the end of this, what do we say? So we have a result, result. Starts off at 0, and we have our result plus equals params of I, and then at the end of this we have sb.append equals, and sb.append again character. So actually, what do we have? Append character sequence. I want to append a string. Can we do that? I don't know that we can. Let's see. Oh, you can. Yeah, there you go. Append string. Sweet. That's what I want to do. So really, I just want to take this. You can, I mean, you can convert this. integer to, we can do it that way. Let's convert this integer to a string. I don't know if you can append an integer. Let's see. It's Java string builder. Yep. And you can just add an integer directly, so you don't need to convert this to a character. So we'll just say x equals params of I, and then we'll say result plus equals x, and then we can append x. And then here, same thing, we can result here. That's pretty much it. System.out, print line, string builder. I think that's all you need. Looks good. Let's see how we do. Okay. Not bad. Relatively easy. Yeah, last time before we got stuck because we were trying to figure out why, trying to figure out how to get this in variable, and it was just a static import, which is like a very unusual use case for Java's import, but apparently you can do that. So there you go. So where are we at? All right, almost 3 hours. That's pretty good. I should go to bed soon. I don't want to keep talk so loud. You know, my neighbors are probably going to sleep now and whatnot. So we have one more, and then we should be done. So let's take a look at that. Java reflection attributes. Java reflection is a very powerful tool to inspect the attributes of a class in runtime. Java reflection is a very powerful tool to inspect the attributes of a class in runtime. For example, we can retrieve the list of public fields of a class using getDeclared methods. So we have Java reflection is a very powerful tool to inspect the attributes of a class in runtime. For example, we can retrieve the list of public fields of a class using getDeclared methods. For example, we can retrieve the list of public fields of a class using getDeclared methods. We can retrieve, sorry, my brain, it's hard to focus sometimes. Java reflection is a very powerful tool to inspect the attributes of a class in runtime. Right. Oh yeah, we've talked about this previously, the Java reflection library. For example, we can retrieve the list of public fields of a class using getDeclared methods. For example, we can retrieve the list of public fields of a class using getDeclared methods. Yeah. Okay, I know that. I've seen that before. It's pretty good. In this problem, you'll be given a class solution in the editor. You have to fill the incompleted lines so that it prints all the methods of another class. In this problem, you will be given a class solution in the editor. In this problem, you'll be given a class solution in the editor. In this problem, you'll be given a class solution in the editor. You have to fill in the incompleted lines so that it prints all the methods of another class called student in alphabetical order. We will append your code with a student class before running it. The student class looks like this. So I have a student class, print all the methods of the student class in alphabetical order like this. Get name, set ID, set email, another method, some more methods. Okay. There is no sample input output for this problem. If you press run code, it will compile it, but it won't show any outputs. Oh. Okay. Well, how am I supposed to know it worked? I don't know. More details. Yeah, I think we need to look at that. I don't know. Okay, it's not really a lot to work with. If there's no test inputs, then like, okay. Alrighty. What was the method? So we have getDeclared methods. All right. Excuse me. Class API. Okay. Okay. Get declared methods. And this is a, what object is this? This is a class object. So we need a class student. So how do we get the class object? We have constructors. As subclass cast. Get classes, get class loader, component type, constructor, constructors. Let's see. Method, methods, modifiers, name, package, resource, simple name, superclass, type name, type parameters as annotation. Looking for how do we get an object of class? Well, I guess I have to read this tutorial, right? Classes. Every type is either a reference or a primitive. Classes, enums, and arrays all inherit from this object, as well as interfaces are all reference types. Examples of reference types include java.lang.string, all of the wrapper classes for primitive types such as java.lang.double, interface java.io.serializable, and the enum java.x.swing.sortorder. There is a fixed set of primitive types: Boolean, byte, short, int, long, character, float, and double. For every type of object, the Java virtual machine instantiates an immutable instance of java.lang.class, which provides methods to examine the runtime properties of the object, including its members and type information. Class also provides the ability to create new classes and objects. Most importantly, it is the entry point for all of the reflection APIs. This lesson covers the most commonly used reflection operations involving classes. Okay. Ways to get a class. All right, that's what we were just asking. Retrieving class objects. The entry point for all reflection operations is java.lang.class, with the exception of java.lang.reflect permission. None of the classes in java.lang.reflect have public constructors. To get these classes, it is necessary to invoke the appropriate methods on class. There are several ways to get a class, depending on whether the code has access to an object, the name of class, a type, or an existing class. Object.getClass. If an instance of an object is available, then the simplest way to get its class is to invoke the object.getClass. Of course, this only works for reference types, which all inherit from object. Some examples follow. Instance of an object is available, then the simplest way to get its class is to invoke object.getClass. Of course, this only works for reference types, which all inherit from objects. So examples follow. Class C foo.getClass turns the class for string. Class C system.console.getClass. There is a unique console associated with the virtual machine, which is returned by the static method system.console. The value returned by getClass is the class corresponding to java.io.console. So what are we looking at here? Object.getClass. If an instance of an object is available, then the simplest way to get its class is to invoke object.getClass. Of course, this only works for reference types, which all inherit from object. Some examples follow. foo.getClass. Class for string, system.console.getClass, a unique console associated with the virtual machine, which is returned by the static method system.console. The value returned by getClass is the class corresponding to java.io.console. Okay. So I have to forgive me. I'm like struggling to focus. I shouldn't have checked my phone. It's such a bad thing to do because you don't know, like, you know, there's, yeah, shouldn't have done that. I should say there are things in my life that can be very difficult to focus when dealing with those things. Let's put it that way. One way of expressing it. Class for string. Right, so A is an instance of the enum E. The get class returns the class corresponding to the enumeration type E. Interesting. Okay, so we can get class. Since arrays are objects, it is also possible to invoke get class on an instance of an array. The return class corresponds to an array with component type byte. So class C, get class, do hash that string. Oh, I see. So this is the byte array with type byte. In this case, java.util.set is an interface of an object to an object of type java.util.hashset. The value returned by getClass is the class corresponding to java.util.hashset. In this case, java.util.set is an interface to an object of type java.util.hashset. Interesting. Oh, I see. Okay. Gotcha. Calling it an interface. I don't know if that's the right way to think about that. Or at least that's not how I would have expected it. I mean, it's the docs, so I kind of have to go with what they're saying, sort of how they define it, but I would not have thought that. The value returned by getClass is the class corresponding to java.util.hashset. Fair enough. The .class syntax. If the type is available but there is no instance, then it is possible to obtain a class by appending .class. The name of the type is also the easiest way to obtain the class for a primitive type. So I've seen this a few times. b.getClass compile time error, boolean.class correct. Note that statement boolean.getClass would produce a compile time error because a boolean is a primitive type and cannot be dereferenced. The .class syntax returns the class corresponding to the type boolean. Class C, java.io.printstream.class. The variable C will be the class corresponding to the type java.io.printstream. Class equals int array of array.class. .class index may be used to retrieve a class corresponding to a multi-dimensional array of a given type. Class.forName. If the fully qualified name of a class is available, it is possible to get the corresponding class using the static method. If the fully qualified name of a class is available, it is possible to get the corresponding class using the static method class.forName. Huh. Interesting. This cannot be used for primitive types. Syntax for names of array classes is described by class.getName. Excuse me. This syntax is applicable to references and primitive types. Oh, okay, I see. So you can use the full name of a class and get the and use class.forName and get a class object for that class. Interesting. This statement will create a class from the given fully qualified name, class C double array class.forName. Whoa. That's interesting. String array, hello java.ling.string. It's kind of a weird name. The variable will contain the class corresponding to an array of the primitive type double, that is the same as double.class. C string array variable will contain the class corresponding to a two-dimensional array of string that is identical to string class. I don't know if this is a typo or if this is intended to be this way. This is like a very strange way of doing things here. C string array variable will contain the class corresponding to two-dimensional array of string that is identical to string identical to string, what do you call that? Array.class. Type field for primitive type wrappers. The .class syntax is a more convenient and the preferred way to obtain the class for primitive type. However, there is another way to acquire the class. Each of the primitive types and void has a wrapper class in java.lang that is used for boxing of primitive types to reference types. Each wrapper class contains a field named type, which is equal to the class for the primitive type being wrapped. Okay, the .class syntax is a more convenient and the preferred way to obtain the class for a primitive type. However, there is another way to acquire the class. Each of the primitive types of void has a wrapper class in java.lang that is used for boxing of Primitive types to reference types. Each wrapper class contains a field name type, which is equal to the class for the primitive type being wrapped. Right. I've seen that before. Oh, so double.type. Oh, interesting. Okay. There's a class java.lang.double, which is used to wrap the primitive double whenever an object is required. The value of double.type is identical to that of double.class. Ah, interesting. Okay. Void.type is identical to void.class. Neat. I like that. I've seen that before. Oh, no, I haven't seen that before. I didn't know that. That's a new one for me. Methods that return classes. There are several reflection APIs which return classes, but these may only be accessed if a class has already been obtained either directly or indirectly. Methods that return classes. There are several reflection APIs which return classes, but these may only be accessed if a class has already been obtained either directly or indirectly. Several reflection APIs which return classes, but these may only be accessed if a class has already been obtained either directly or indirectly. Methods that return classes. There are several reflection APIs which return classes, but these may only be accessed if a class has already been obtained either directly or indirectly. Methods that return classes. There are several. Sorry, I'm having a hard time focusing. Like I said, some things are just difficult. Some things in life are just extremely difficult, and actually, like I said, painful. I said in a few previous videos that I experience a lot of pain in my life continuously, so it's sometimes hard to focus. Methods that return classes. There are several reflection APIs which return classes, but these may only be accessed if a class has already been obtained either directly or indirectly. Methods that return. There are several reflection APIs which return classes, but these may only be accessed if a class has already been obtained either directly or indirectly. Okay, fair enough. Get superclass returns a superclass with a given class. The superclass of javax.swing.jbutton is javax.swing.abstractButton. Class.getClasses returns all the public classes, interfaces, and enums that are members of the class, including inherited members. So class wildcard array C equals character.class.getClasses. That's really interesting. Character contains two member classes, subset, character subset, character Unicode block. Class.get declared classes returns all of the classes, interfaces, and enums that are explicitly declared in this class. Class wildcard array C character.class.get declared classes. Character contains two public member classes, character.subset and character.unicode block, and one private class, character.characterCache. How are we doing on time? It's been 15 minutes now. So declared classes, interesting. This classes, declared classes. So get classes are all the public ones. Contains two public member classes, subset and Unicode block, and one private class. So declared classes the public ones. Classes are all the public ones. Declared classes are public and private. Interesting. Get declaring class, get declaring class, get declaring class, get declaring class for class, field, method, constructor. Turns the class in which these members were declared. Anonymous class declarations will not have a declaring class, but will have an enclosing class. Interesting. Get declaring class, get field, function field. Field out is declared in system. System.class.get field out, field f. Public my class my class, static object O equals new object. Public void m, o.get class, get enclosing class. Class C. The declaring class of the anonymous class defined by O is null. Interesting. Huh. F.get declaring class would be system. Enclosing class would be my class. Declaring class is null. Get enclosing class returns the immediately enclosing class of the class. Thread state class, get enclosing class. Closing class of the enum thread.state is thread. public class, my class object, get a closing class, anonymous class defined by O is closed by my class. Okay, got it. Do I need to read more? I might as well. Yeah, might as well keep going. Examining class modifiers and types. A class may be declared with one or more modifiers which affect its runtime behavior. Access modifiers, public, protected, and private. Modifier requiring override, abstract. Modifier restricting to one instance. Static. Modifier prohibiting value modification, final. Modifier forcing strict floating point behavior, strict FP. Annotations. Examining class modifiers and types. A class may declare with one or more modifiers which affect its runtime behavior. Not all modifiers are allowed on all classes. For example, an interface cannot be final, and an enum cannot be abstract. Okay. Java.lang.reflect.modifier contains declarations for all possible modifiers. It also contains methods which may be used to decode the set of modifiers returned by class.getModifiers. The class declaration spy example shows how to obtain the declaration components of a class, including the modifiers, generic type parameters, implemented interfaces, and the inheritance path. Since class implements the java.lang.reflect.annotated element interface, it is also possible to query the runtime annotations. So yeah, that's pretty neat. We used something on the regarding the runtime annotations on another problem, so that's kind of nifty. Excuse me. I don't know. Production code should handle this exception more gracefully. Nice. That's something that I would write. Something that I would write. All right. I don't know if I want to read all of this. Not that there's much more to read, but I think we can try to solve this problem now. Let's just see. So, student class, we want student.class. Methods, we want method or just student.get these are the same things. We want to get the methods, declared methods, I think. So they said we want all the methods. So not just the declared methods, all of the methods. Okay, so it's declared methods, right? Not just the public methods, but the declared methods. Okay, method list. So here we can just go through the array of methods. Method M. Methods, presumably this is what we're doing. So we have an array list of, now what's interesting is these are the strings, so we actually want the method names. Okay. So take a look at methods and look at the names. Yeah, just .get name, I think. Simple, and then sort, fair enough, and print. Okay, I think that's all we need. Test your code against some custom input. What custom input? What's the input? I don't know. We're just gonna go for it. Okay, it worked. We got it. Success. No hidden test case. All right, we solved all the challenges in Java. We did it. I don't know how many weeks we were at this for. We're doing this for a while. Yeah, we were at this for a while. Great. So we did all the Java questions on Hackerrank. Whew. Now, what's interesting is that's going to be it, I think, for me for today. I definitely need to sleep. I don't know how many hours we put in, but it was quite a bit of reading. I really do need to solve the JavaScript one. I kind of have to review Python again because I've been testing in Python some of my interviews I've been going for. We can go get some certificates too. That would be good for problem solving in Python and all that. I probably should just get all the certificates on the site, quite frankly. That's probably what I should do. What I want is, yeah, I still need to go through Ruby. We did C++, we did Java, we did Linux shell, we did Python. I think I should do Ruby, and I really should do all of these, I think. Pretty much everything on the site I think would be good. But I think the 10 days of JavaScript would be good. And then I kind of want to look at the AI and the statistics thing. I probably won't do that anytime soon because the jobs I've been looking at are not really focused on that. But it does look really interesting. I don't know how many of these there are. I think all of these are actually, oh, these are just regular problems. Oh, that's interesting. These aren't actually, that's interesting. These aren't actually like strictly, oh wow, I don't know what to make of that. In other words, like if you go to problem solving, like you just say algorithms, yeah, there's 560 of them, and then they actually don't include the machine learning problems. That's interesting. Functional programming. Yeah, these have, it doesn't tell you how many there are. That's kind of neat. Huh. Yeah, I think these are all problem solving though. I think all these are, I don't know what to make of it all. I'm a little confused. They have a lot of problems to work on, but I don't know how many there are, you know, that's the thing I'm kind of curious about. No hard regex problems about medium. There are a few. I don't know, not very many. A lot of easy ones. Yeah, SQL. 80 it looks like. Oh, I don't know. How many of these are there? I don't know. How about advanced? I don't know. Hard. Only a couple. 15 days. Handful of mediums. Yeah, there's a lot of practice to be done, to do. I think just the 10 days of JavaScript is what I'm going to go look at next, and also Ruby. I think once you get the first star, it'll tell you how many problems there are. I think when you solve the first problem, it tells you how many there are. So I guess I need to. So interesting. Each of these practice sections are their own sections. There's a set. So these are actually separate from. I think data structures and algorithms are together though. Yeah, it seems to be that they're kind of in one section. Yeah, 563. And then what about the mathematics? Yeah, this is its own portion as well. A few mediums. And how many hards? There should be quite a few hards, I think, of the maths. Little Ashish is huge donation. Keel and GF. Dancing Bears, help Mike. Meta and his laziness. Pretty interesting. I don't know. But yeah, I think the thing to focus on next will be Ruby and JavaScript, because those are sort of the things I've been interviewing in lately. Just wanted to review Java again because oh yeah, there's certifications we can do too, right? So probably you can do. Oh, we already did Python. Really should do all of these, I think. The only ones I think I wouldn't be comfortable doing would be maybe Go and Angular, C#. Some of these actually I would need some practice. Actually, I think I would need practice on all of these, really. Java is probably the one that I could do now. Maybe I should do that now. Maybe I'll do that another time. JavaScript. I should really do these. I think I'm gonna do. I think tomorrow. Tomorrow I'm gonna perform the certification for Java, and then I'll do. We have either Ruby or JavaScript. We'll do. See, does it tell us how many Ruby questions there are? It doesn't. We need to do the first problem, and then we can see. Yeah, definitely want to practice Ruby. And then on the docket we have Ruby, JavaScript, those certifications, the Java certification, the Ruby. I don't think there's a Ruby certification there, and then JavaScript certifications, the medium and the basic. And I think from there, I'll be in pretty good shape. That should take me a while. It could take me like a few days this weekend, and then after that, I mean, depending on how far I get it, I would have. There's some C++ like review that I want to do of just like the language, just reading like the language documentation. And yeah, I don't know. I mean, nothing too particularly exciting, but I'm just kind of slowly working through all these problems on the websites. Pretty interesting. I definitely need. So let me just see before I get off. Let me just take a look at LeetCode, because see if I'm still logged in there. I'm going to clear my cookies now too, I think. Yeah, so I still have a lot of problems to solve on LeetCode. If we go to the previous version, that's neat. So there's a little button there. Yeah, we have 31%, almost 31% solved. So we still have another 1,400 problems to solve here, roughly. A little less than 1,400. So that's a lot. That's going to take us some time. It's quite a lot of problems. So yeah, so that's another thing that's pending. Eventually, I'm going to look to solve all of that, and then I'll be pretty good as far as algorithms and data structures go. Yeah, I think the main issue I'm having now in interviews is like one, language proficiency, and two, I need to practice a little bit more of the like on-site interviews with like another developer. You know, when you're building some open-ended problem, working on some open-ended problem, and like writing code to do that, and then to remembering to write some code, because that's what they judge you on, that's what they grade you on, is the code that you write. So you kind of have to write something. Yeah, so okay, we got a lot of work to do. Got a lot of work to do, but we'll just keep going. We'll get there. Okay, all right, I'm gonna go. Yeah, let me go. Thank you again for watching. Talk to you soon. Have a good rest of your day. And I'm gonna remember to clear my cache here for clear my cache here for my what was I saying? Clear my cache for my web browser. Yeah. So okay. So take care. But yeah, great. We finished the Java